Hi guys! Last time we were able to identify in and out messages, but the user information is still missing from the chat view. Let's get to that. Let's say you log in the app and there's an incoming message. Last time we said that your app instance can't figure out who sent you this message. Well actually, we do know its sender ID, which is also the Firebase user ID of its sender. We connected these two via the JSQ sender ID in the last lecture. However, we don't know the sender name, the profile photo of this user, and things like that. One way to overcome this issue is to let the sender upload this information together with the message data. But there's tons of reasons not to do it this way. The number of messages is typically large, so it's redundant and wasteful to save user information in every message. Furthermore, if we want to extend the app to show user profile, it's then very hard to do so. Intuitively, what we should do is separate the messages and users by creating a user database on Firebase. It's a sort of convenient table for us to look up user information if needed. It should index all authorized users in the app. A user in this database should contain information like user ID, username, user profile photo, and things like that. Basically information we want to query based on what we have. We build the app so we can choose to use what we have. Here we'll use this authentication, like your Google username and profile photo. The Firebase user ID on the message sent by the corresponding user should match up so that we can access the user information when retrieving and displaying a message. Then we don't need to store user information in the messages. We can stop here if we build the chat function ourselves, but recall the JSQ requires the sender name to be encoded into the messages. So here, we'll store sender name together with the messages, but you're free to refer to sender name on the user database. All right, let's code it up. Now, whenever a user sends a message, we'll also encode the user display name into the message. Until now, the sender display name is set to a fixed string for every message. This value was encoded into the message data and uploaded to the database in previous lectures. So, on the database, every message has the same sender name. This is not correct. Ideally, the sender name of a message should be the username of the user that sent this message. But where do we get this username information? Well, you build the app, so you should be the one who decides that. For example, you can build a view and let user input their display name. But here we do something simpler. Our app has two types of users, anonymous and Google users. We can access the Boolean property named anonymous of the current Firebase user to check if this user logged in anonymously or not. If not, this user logged in using the Google account. For anonymous users, we'll give them the same display name. It's up to you, but we'll just say anonymous. All right. Otherwise, this user logged in via Google, so let's just use the Google username by the Firebase authentication of the current user, access the Google display name. By the way, the current user variable is optional, so let's unwrap it. After that, the current user variable is not optional anymore, so there's no more unwrapping thing. All right, let's move the current user ID stuff up here for a write order. All right, again, there's no more unwrap stuff. All right, good. Let's delete these things. The code is not indented properly, but I'm gonna just leave it there and fix it later. All right, now let's delete all messages on the database. Those are the old messages with incorrect user display names. All right, let's check it out. Type something like first message and send. Let's see. Oh, good. It's sent by an anonymous user, which is me. Now, let's sign in with Google and see. All right. Okay, this is the message we just sent. Let's send test. All right, let's see. Perfect. Actually, let's unwrap this optional Google username. Intuitively, it could be the case that some users don't specify the display name on their Google accounts. All right, let's test the app again. Type test and send. All right, let's see. Great. Now construct the user database. We'll work with Google users first. In the login view controller, get to the login with Google method. This is where we get the Google authentication information after the Google sign-in. Let's print out the Google photo URL. Note that this is the current user information and for now can't be accessed by other users. For example, I can't see Google Photos of any other Google user. That's why we need a user database to look up. Alright, here's the Google profile photo URL. We can preview this photo directly on the browser. Great, this is our profile photo on Google. Now we'll push this information to the database so that others can use the other users in the app can access it. So let's create a new user on the database to hold the information. Actually, we need to import the Firebase database library. Alright. Now, let's access the Firebase database root location by calling the reference method on the shared instance of the FIR database class. Add to this root location a child reference named users, because we'll save all app users to this child location. Each child of this node will be a user. Let's use the authentication ID to identify this user because it's random already. Now, push the current user information to this new user location. We use a dictionary to hold the user information, like user display name. Here, we use the Google display name of this current Google user. But you can do differently, like let users input their names. For convenience, we'll also store the location ID in here so that we can get it easily if necessary. Because we use the authentication ID for the reference ID, so this value is the ID of a Google user. We'll also save a user profile photo to the database, using the profile photo from the Google account. Again, you can do this differently, like let the user input a photo. Alright, let's sign in with Google. Great, the user database was created. This is the uploaded Google user. Now, do the same thing for anonymous users. Let's copy over the user data to the anonymous login method. As before, the display name will be the same for all anonymous users. And these are now anonymous users. We need to change variables accordingly. Currently, we don't know how to get a photo for the profile photo data of anonymous users. So let's leave it blank for now. Now test the app. Let's log out of this Google account. Oh, by the way, let's delete all old messages in the database and start over. Okay, good. Now, let's sign in anonymously. All right. Great, there's a new user on the database. Wait, there's a typo. All right. By the way, you can also modify users directly on the database in the development process. Now, let's send a message and see. All right, send. Great. This is the message just sent by this anonymous user. So, by now, we know how to construct and upload to the database user data. Let's learn how to retrieve user information from the database. We'll use a function named observeUsers to retrieve all users in the database when the app launches. This function will be very similar to the observeMessage function. We'll call method reference on the FIR database shared instance to access the database. Then look at the location of all users, and listen to some certain event occurring at this location. We're interested in the events that some user has added to the database. Whenever there's a new user, this listener will return a data snapshot holding this new user information. All right, let's print the value in this return data snapshot and see. This listener will return any newly added user and all existing users on the database one by one. Good, this is the two existing users in the database. What printed here are optional dictionaries. As with messages, we can unwrap these dictionaries to get the values inside. A snapshot can be nil because it's optional, so let's check if the unwrapped dictionary is nil or not. This dictionary is unwrapped from the snapshot value. After being converted to a dictionary with string keys and any object values. We use any object values because they can be of different types. So let's print this dictionary again and see. Later, we'll modify this function to retrieve only users we're interested in. All right, let's sign in with Google again. There should be no new user because we're logged in the same Google account before. So send a new message. All right, good. It's working fine. Now let's log in anonymously. All right, great. There's a new user who hasn't sent any messages. So we shouldn't retrieve this user when pulling the messages. Meaning, after retrieving a message, we should only get the information of the user who sent this message based on its sender ID. So we need to modify the observe users method so that it takes in an ID string. When we upload a message to the database, we encoded the sender ID to the message. We'll now use this ID as an input of the observe users method to look up the corresponding user in the user database. So now the event we listen to is value instead of child add. Basically, we want to retrieve all information of the user with the input ID. All right, good. And also, we no longer need to observe users when the app launches, because we're doing so when retrieving messages. By the way, this instance method should be called on self because it's called inside a closure. All right, let's see. Okay, something's missing. Oh yeah, after we know the sender ID of some message we retrieved, we should observe the user with this ID instead of listening to the location of all users. All right, great. You can see that only 2 users were printed to the console, the ones who sent the 2 messages on the database. Their IDs are wrapped into these messages. The other user was not polled because this user didn't send any message. Now, let's do something with the retrieved user information. We only want to show user avatars, so let's take it out by extracting the user data dictionary value with key profile URL and converting this value to a string. And then set up this user avatar based on the photo string we've just got from the user data dictionary. All right. Okay, good. Let's see how we can implement this setup avatar method. Its input is, of course, a photo URL of type string. When we uploaded user data, we let photo URL of anonymous users empty string, so it's probably wise to check if the input photo URL is empty or not. If it's not empty, then this is a profile photo URL of a Google user. By the way, we should call this instance method on self in this closure. All right, we have the photo URL. Now let's see how we can display the photo to the chat view as a user avatar. Recall that JSQ has a required method for user avatars. We let it return nil before just to make the app run. We now return a sort of JSQ avatar object by using a method from the JSQ avatar image factory. The method name is avatar image with image. We create this JSQ avatar object from some UI image. We'll initialize this UI image from some default photo and adjust it accordingly to different user types later. We'll choose a photo from the resources folder, which is this one. After this step, all users, Anonymous and Google, will use this photo as their avatars. But we'll change that shortly. Next, the diameter parameter kind of defines the size of the avatar. You should play around with it and choose the size that you like. We're happy with 30 after a few trials. All right, good. We basically converted a default photo into something that JSQ can use for user avatars. Now, note that now all users have this default avatar. Yelp, let's differentiate them. Now, for each cell that displays a message, consider the corresponding message from the message array, based on cell index. The avatar of the sender sent this message depends on the message itself, specifically on the sender ID. Basically, on the type of this user, we use a proper avatar. So let's define an avatar dictionary holding the avatar object for each sender. Each avatar object is, of course, JSQ friendly so that the JSQ can display it. This is the same type as the avatar object returned by the JSQ avatar factory we were just working with. You can see that from the declaration of this avatar image with image method. All right. Currently, we're returning the default avatar for every sender, and that's kind of bad. The avatar should depend on the sender type. So we get this avatar from the avatar dictionary we've created, based on the sender ID of this message. In short, we check the message sender ID, then get to the avatar dictionary to look up the corresponding JSQ avatar object for this user, then display. The only thing left is to construct this avatar dictionary. We got the sender ID from the message, then pull the corresponding user from the database. Then we got the avatar URL if this user has one. Our goal is to convert this avatar URL to a JSQ avatar object in the avatar dictionary for this user. All right. If a sender does have a profile photo, then the avatar, actually wait, we need something to specify this sender. It's the sender ID of a message which we used as an input for getting the sender after retrieving this message. So now we inject this sender ID into the setup avatar method. Basically, we're creating an avatar for the sender with this ID. That's all. Now, if the sender with this ID has profile photo, we'll create a JSQ avatar object for this sender based on the profile photo, and put it in the avatar array at the index corresponding to the sender of this message we're considering. We create this JSQ avatar object from the JSQ avatar factory using the avatar image with image method. The input UI image is, of course, instantiated from the sender profile photo, but we only have the profile URL. So we need to create this UI image indirectly via an NS data object, because Swift doesn't let us do it directly. We can get this NS data object by instantiating it from the user profile photo URL. So the input is some NS URL object. We name it file URL. Finally, we only have the photo URL string, so we get this file URL by instantiating it from some string. And this string is the non-empty URL string holding the user profile photo. All right, let's see. Okay, let's unwrap the optional NS data and file URL. All right, I think we're good. Now, if this is an anonymous user or a Google user without a profile photo, then for the corresponding JSQ avatar object, we're just going to use the default photo as before. So let's copy over the command creating the default avatar we commented out before and use it here. All right, great. Let's run the app and check it out. All right. Okay, here's the app. Okay, something wrong. Oh, we retrieved the messages but couldn't display the user's avatars. After we pulled a message, we read off its sender ID. We then looked up the user database to retrieve the corresponding user, then created an avatar from this user's profile photo. That should do it, but why it doesn't work? All right, perhaps we should send a message and see. Wait, what just happened? Oh yeah, after we sent a new message, we reloaded the table view, so that's why it worked. So similarly, we need to reload the table view after setting up avatars. The way it works is if we want to display new data, we need to reload the table view. But before, the table view was never reloaded after we set up user avatars. All right, let's send a photo. Let's try a different one. So it might take some time. All right, great. Now let's test Google users. We're pretty much done with basic functions. We'll factor the code and build some extensions next time. See you then.